Cool. Can anyone hear me?
Yeah.
Oh, really? Okay, awesome. Wow. It said like muted, but that's great. All right, I thought I was gonna have to fix things. Hello. Thanks for coming. Yeah, I actually like made a bunch of fancy slides, like fancier than usual. So let me like bring those up and then I'll show you how you can get them because I figured out how to make it so that you don't have to like just scroll through a Python notebook. You can just like have real slides like that you can look at with me, right? So yeah, cool. Let me paste the link to that in the chat. It is. Okay, can people try clicking that link I just put in the chat? Because like I literally just figured this out. But hopefully, if I did it right, it like it lets you actually follow along with the same slides that I'm using, right? Cool. Okay. So yeah, let's get started. But yeah, let me screen share. Like the URL is still the same, and I'm pretty sure I updated it. Meaning, like if you scroll down to week 3 on like the table of contents on the little GitHub that I sent, you should. One second. Yeah. Cool. You should. Hopefully, there's a link to this. Is what I'm saying in the GitHub. Like when you go to like this page right here, this main page, and you like scroll down to the bottom. Cool. Also, yeah. Sorry for the weird. Well, it's like great surroundings, but random surroundings. Yeah, at like 7 in the morning, a construction started like outside of my window, and all my furniture started shaking, and I could not do the office hours where I live. So now I'm next to this tree. It's good stuff. You love to see it. So cool. Yeah, hopefully it's the same link as before, but there's this new like thing that I set up here. Cool. Let's do it. Great. So we're doing causality and the scientific method this week. We're kind of doing it. Yeah, it's a little bit reversed because I like went too far into the code last week. So I'm kind of like, I'm emphasizing the theoretical stuff more today than I did the last 2 weeks. Just so you know like why it looks a little different. Yeah, I put this here, but hopefully if you're here you knew this. That's the link. It's the same link for both sections. Cool. So we're just gonna, I'm gonna talk about homework 1 like ultra quickly because we just have to like go through this causal inference stuff. Great. But the causal inference stuff is like, we'll recap. Like, I think the very first week I had a slide or two on like, what is data science? But we're gonna like dig a lot more into that now, right? Like scientific method and like measurement. Then, we'll go from, okay, well, like scientific method, right? That tells us a method for testing hypotheses, but what are those hypotheses? And the hypotheses are about like, there's like easy level, like mathematically verifiable, like truth, like closer to truth verifiable thing correlation, right? But then what Prof. JR talked about in lecture is like causation is the holy grail, right? So like correlation we can get with whatever, we'll see. But causation, like moving from correlation to causation is like a quantum leap, right? And then we'll talk about, don't go into the details of causality, the fundamental problem of causal inference, which is a real doozy, but how do I put it? It can also get like overemphasized because we'll see like statisticians, right? They've spent like 400 years now trying to solve, well, I'll say 200 years. Like it's Hume, if anyone's into philosophy, history and stuff. But so like 200 years, like statisticians, they've all just been trying to be like, how can we like chip away at this fundamental problem of causal inference, right? And they've gotten like pretty far. Anyway, So don't get your hopes down, hopes shattered. Yeah. And then experiments, right? So like if we want to do causality, like, okay, where I want to like wake up in the morning and do something to test some causal hypothesis. Like what do I actually do, right? And that's experiments, whether actual like controlled experiments or observational studies where like we simulate, like we try to get it as close as we can to being like a controlled experiment. Cool. So yeah, literally all I'm gonna say on homework 1, because like you have other resources for getting this done and like resolving any issues like Piazza and all that. It's just, yeah, here's the link. Oh, didn't open in a new tab. That's good. Yeah, here's the link. And yeah, you spawn your server and hopefully you can just follow along with my slides from last week. And if not, like Piazza or emailing me. Yeah, because like if it helps you like specifically as like students in my section, like yeah, I think I mentioned, right? I like wrote the auto grader and everything. So like tech just like by design, like I would know how exactly how everything's gonna be like graded, and like feel free to like ask me like, oh, feel free to ask me a question that's like, oh, do you think like the auto grader will like be able to grade this if I did it? I'm scared I did it in a weird way or something like that, you know? So I won't be like confirming whether or not you got the right answer, but I'll be saying like, I'll either say, yeah, basically what I'll say is, oh, interesting, I hadn't thought of that way of doing it before. Thanks for showing me this. And then I'll go into the auto grader and I'll make sure you don't get points off if it's a correct solution, right? So like hopefully you don't abuse that. Like you don't just like send me every question and say like, hey, how does this look? How does this look? How does this look? But you know, if there's some, it's all multiple choice, right? So like this one you shouldn't be worried about the auto grader, but yeah, I was just sorry. That's not as relevant for homework 1. I'm saying for homework 1 and for future homeworks, like you can always email me. It'll become more relevant in future homeworks where you're actually doing like coding and stuff. But just wanted to put that disclaimer that applies for homework 1 and all the homeworks after. So yeah, that's the link. It's there. That's all I'm gonna say. Raised hand. Yeah, what's up?
Oh, I just wanted to ask for the questions that like kind of ask for like not just multiple choice, but like kind of ask you to input something that's gonna be like manually checked, right?
Yeah. Sorry. Wow, I should have said that. Yeah. That's an amazing that was an amazing question. I was supposed to say that. Yeah. Yeah, it's definitely not auto graded. Yeah, not auto graded. Like basically what the auto grader does is it just like scoops those questions out and just gives them to the TAs to grade by hand, right? So like you instantly, like right when you submit, like you instantly kind of can get a grade on everything but those there's I think 3 questions. Yeah. And then those 3 like I'll go through by hand. So don't worry about that one. For those just like, yeah, you don't have to worry. I'm gonna look at it with my eyes. Thanks. Cool. So data science, right? Recap from it's like 2 weeks ago now. But yeah, I'm kind of just like taking stuff from Prof. JR's slides in a way and like highlighting what I think is important or like what confused me when I was like learning data science and all that. So, you know, just trying to like help, like maybe there are ways to highlight certain things that are important that maybe like help it click in certain ways that like it didn't click yet from the lectures or something. So anyway, the point is like you'll recognize a lot of this, but like I'm kind of highlighting what I'm putting my specific little underlines on it, right? So yeah, more than numbers. That's like the first thing I think of when I think of data is like you want to get past the misconception that oh, like if you didn't measure it numerically, it's not data, right? I mean, I'm like biased and it's like you know, it specifically affects me in the way that in the sense that like my whole like master's and PhD and everything all uses text data, right? So like words and phrases and stuff. And yeah, you'll get a lot of pushback if you do that from like people who are like, well, a computer can't read a book. I don't know what you're doing. You know what I mean? And it's like, it can't, and yet it can do stuff that like, think of like processes that humans can do. Like, oh, how many times is like Africa mentioned in this book about the Cold War? Like, that's what I've been doing like this past week. I could do that as a human, right? I could go through and I could like underline every time the word Africa appears in this, it's right here actually, in this like 800-page book, right? But really, I also could just like get a computer to count it, right? So stuff like that. The point is like, there's no like number. Well, if you're making a number, but the data isn't really the number, right? The data is like the book, like data. There's the book as data, right? The text in the book, and then you derive like a second piece of data, which is numeric, right? It's just, I don't know. I won't harp on it, but like, also like on this point, remember what we talked about, where like actually in a computer, letters are just actually numbers. Like there's just a code, like 1 is A and 2 is B and 3 is C. So it's actually, it is kind of numbers, even text, right? It's just your computer is doing a bit different type of arithmetic with the letters than it would with like numbers with like normal mathematical addition and subtraction, right? Like we saw like the plus sign, right? It becomes concatenation. And the multiply sign, it becomes repeat this letter or this string, right? But it's still like, there's still these like data, like these algorithms, these operations we can do, even though it's not technically numeric as such. I put this part like symbolic systems because, yeah, if you go to like Stanford, there's this like really popular major there called, well, I don't know if it's really, it's like, I think it's one of the most popular majors called symbolic systems. And it's like, you spend like 4 years, right? You do like a whole undergrad program. And it's kind of driving this point home that it's like restrictive if you think like, oh, algorithms, and then those act on like numbers, right? Because if you think about it, like there's a generalization of that, right? Where it's like symbols, systems of symbols, right? So like the English language is a system of symbols. Arithmetic, calculus, these are like systems of symbols, right? Music, art, like these are all systems of symbols in a way. And if you like want to geek out on that, there's that book, Gödel, Escher, Bach. You can Google that, it's fun. And it's all about like the symbolic systems of art and math, or art and music and math. It's fun. But the point is like, they have a whole major that's just about like data that's not just numbers, right? Cool. Just want to drive that home. And that it doesn't speak for itself, right? But it must be interpreted. Prof. JR talked a lot about that, and I think that's like super important. Yeah. This is my favorite clip ever. Maybe it's a, how do I put it? It's a prank TED Talk, right? If you've seen TED Talks, you might like recognize this, but it's just my favorite because it shows like, it's just as valid of an inference from data that this guy is making as like any other. It's kind of like, it's extreme thing to say, but in a way it's true. Like he's like deriving a claim from the, anyway. I'm mostly including it as like a joke, but you'll see. Wait. There's no audio, is there? Is there audio? Well, you can go, because I can't get the audio to work, but oh well. The point is,
do you want us to watch it in,
oh, yeah, it's not like, it's just like it's just funny. He just goes like,
oh, okay.
Yeah, he's just is like,
is there like a link that you can drop in the chat?
Yeah, I mean, it's in the chat. This is from the slides. It's right. Does the chat not like, I can paste it again. I'll paste the specific like link to the slide. But it doesn't matter. It's just, he's just like a weird prank guy, and he goes on like, everyone thinks he's giving a TED Talk, and he's like, we looked at the data, folks. We looked at the data. We crunched the numbers, and what we found, it really surprised us. It turns out culture is a sewer. And that's it. That's just his whole, it's like TV, it's terrible. He just spends like 18 minutes complaining about what he wants to complain about. He's like, yeah, we computed the standard deviations, and you know, this TV show is really annoying. It's terrible. It's just, yeah. I can't like explain why it's fun. It's explaining a joke is not fun. But anyway, science. So, right, that's like abuses of data. And now we're talking about abuses of science, right? Because abuses of science are the idea that like, oh, it gets to some sort of like Platonic ideal of truth, right? But Plato, right, and like all that stuff is about oh, like finding like transcendental truths about the world. That's kind of like this old like Greek, like Plato Aristotle model of like knowledge and like learning things about the world, right? Like not that it's bad, it's just kind of weird that like people still have that because like modern like 20th century science is all based on falsification, right? It's like that's the entire thing. You never like know, you never like learned a thing like, oh yeah, that's true. You just learn that it's like false or you haven't yet proven it false. It seems like really depressing, and yet like pragmatically, like it can do stuff, right? Like you can get us to the false or you haven't yet proven diseases, right? Like um, it's pretty powerful, right? Like it literally has an impact on like society and humans, even though it has this like depressing like philosophical thing, right? Where you're just like, you're never understanding truth. You're just, you just have certain theories that you're like, wow, this theory is pretty wild. Like I've tried to falsify it like 5,000 times in all these different ways and I still haven't, right? Like those are like the most, like that's the, yeah, that's kind of like the holy grail of scientific method, right? It's like, wow, I've done so many studies trying to like disprove my theory and no one can disprove, right? That's the ideal, right? This is like Karl Popper, who like sometimes you'll hear it talked about like, oh, the Popperian scientific method. The point is just like, insofar it's very stark. It's like, insofar as we're talking about reality, you have to be able to like say that it's false, or you have to actually be able to go and do something to falsify it, right? Your theory. And insofar as it's not, you can't do that. It's just not like about reality. It's a when he says reality, he's being like pithy. It's really just meaning like you're making like a metaphysical claim if you can't like falsify it, right? Which is fine. Plenty of things in the world are metaphysical, right? Like emotions and stuff, right? They're all like very metaphysical. Like we don't, it's not like logical, like true false statements, and like that's fine. But he's just saying like on pure grounds of like doing like pure science, right? There's like social interpretation and all that later, but like when you're just sitting there doing science, like you need a falsifiable hypothesis. And yeah, I there's a whole, you know, disgusting like 500-page book that he wrote called The Logic of Scientific Discovery that I like copied and pasted this out of. This is on page 361 if you want to just cut to the chase. But the point is like, dude, you can either like believe him that this is like the most tractable model for science, inference about phenomena in the world, or you can read the book. Yeah, it's fine. I wouldn't read it. Just hopefully you take our word for it, or you see through like the examples of like, oh, people using this have been able to like do things that say in medicine and stuff that people were not able to do before they started doing this falsification stuff, right?
Professor, I think you might have, the internet might have cut out.
Started focusing on like cool.
Professor,
So can you hear me at all? Is that
could you repeat like what you said, because I think it froze for some of us.
Okay, but can you hear me or?
Yeah, now we can. It cut off for a while.
I'm so sorry. This is terrible. Yeah, I wish they had told me they were gonna do construction and stuff. But what can you do? Oh, I'm gonna try switching to my. I'm gonna try joining the meeting with my phone really quick, because then I can use my data. Give me like 30 seconds to do this. Sorry, it's terrible. Okay. I'm clicking the thing. This could either go really well or really terribly. We'll see. Okay. Sorry, this is like insane. All right, feedback loop. Great. Okay, can people hear me any better? Oh, alhamdulillah. Thank you. All right. So, okay. Just getting my bearings. All right. So, great. Where were we? Yes, science. The last thing was just, yeah, having humility that it's an imperfect snapshot. It's always an imperfect snapshot. When you see like a how do I put it? When you see a news article that says like, oh, new study proves that blah blah blah, or new study shows that blah blah blah, like you have to basically just throw that out. Like, just to be honest, you have to just be like, that's like, science is a collective endeavor, right? Going to this slide, like, it's a collective endeavor that's happened over like hundreds of years, right? There's not going to be one study that's going to like prove or like show something once and for all, right? The point is like you add up the like findings of like hundreds and hundreds of studies, right? Over decades and decades and centuries, right? So great. Cool. And this is a slide from Prof. JR's presentation, where it's just like showing that it's not like, it's also not like a one-off thing, like a, right, in the same way that it's a collective endeavor and that it happens over like hundreds of years. It also is a cycle, right, between data and theory and data and theory and data. So like you're not done when you've collected the data about your theory and looked at it, right? And you're also not done when you've taken that data and you've come up with a new theory, right? Like it's a cycle, right? Like you could take this little figure from Prof. JR's slides and like imagine putting it in a circle, right? Just data theory, and just over time, right? You like kind of like hone the theory more and more, right? You kind of figure out what's happening more and more, or you figure out like particular details, those types of things. This is like the slide that, yeah, Prof. JR and Prof. Sperling like wanted you to memorize and like keep using. And you'll see, yeah. So Prof. JR and Prof. Sperling talked about that a bunch in lecture. Yeah, sorry, I have to like stop the phone thing. I'm just gonna go back. Yeah. All right, because I Okay. Yes. That was the last. Now we're gonna do a real presentation. Okay. And I'm just gonna like, if the internet goes out, I'm really sorry. If the internet goes out, just go through the slides at a certain pace, I guess is the best thing that I can say, because yeah, I had everything planned for like giving the lecture. I spent like hours and everything on this, and then construction happened. Yeah, it's fun stuff. So I just wanted to put this slide to, and people can hear me?
Yes.
Okay, thank God. Okay, so yeah, put this slide because like you're gonna see it over and over again, right? I'm not gonna like talk about it so much because it's gonna get emphasized so much in lecture, but just like putting it in front of your like face as much as possible, right? Just showing you like the repeat and extend is really what I want you to focus on here, because yeah, you're either testing it with different data, being like, oh, like I didn't really like that. That data set had a lot of like drawbacks. Let me go and try to collect a better one, right? Or you refine your theory like, oh, actually that data was like, you know, pretty good, but it showed me that like there's a huge flaw in my theory, right? So it's kind of like, it's not this like random kind of, oh, I'll just keep doing stuff, seeing what works. It's more like it's a guided, right? Like you take the result of your study and you use it to come up with your next one, right? Like, by the way, like for practical purposes, like if you ever decide to go into academia, like you actually usually do a lot of like just testing your theory with different data. Like I like just in my like lab, we have like 5 papers, right? And it's all just a single theory called like monopsonistic labor markets. You don't have to know what that is, but like testing the degree of monopsony in labor markets, right? That's like my like research thing, other than the Cold War dissertation stuff. But the point is like we have like a bunch of papers where we just have like different sources of data, right? Like some are from like physical labor markets, you know, like out like going into your job markets. Some of them are like online job markets, like Amazon Mechanical Turk and stuff. But the point is like we're just like, oh, does this theory work in this like realm, like just in the US? Does this theory work in like the international labor market? Does this theory work in the online labor market, right? So yeah, I do like in like economics and like political science and stuff, like it's a lot of, at least it should be, a lot of like testing your theory with different data, right? Because every like data set is kind of this random like flashlight that you're shining on a particular part of the phenomenon, right? So like the more different sets of data you collect, hopefully, if you're doing it like in good faith, like you're uncovering more of the bigger picture, right? Wait, do people know the parable of like the elephant? Like there's a bunch of people like in the dark and they're like, what is this thing? Like, sorry, my phone is being weird. They're like, oh, what is this thing? Like one person touches like the trunk and he's like, I think this is like a hose, and one person touches the tusks. I can't remember if elephants have tusks or not. And he's like, oh, this is like a horn or something, like just like a horn that you blow into. And then another person is like touching the tail and is like, oh, this is like a rope, right? But they're all like not getting it right because they're just looking at these individual pieces, right? But if you like could get all those people to be like, oh, wait a minute, it's the same object. Oh, and they kind of like piece together, they could get like the full picture of the elephant. I don't know if that helps, but that's like a famous thing, right? It's like in science, you're kind of just every data set, every like study, whatever, you're always kind of just, yeah, shining a tiny little mini flashlight on a tiny little piece of the full picture. Cool. And then like, but there's, I would say, how do I put it? So in this, yeah, for measurement issues are like important in the 21st century, especially in a way, like with like modern data science methods and stuff, specifically because data science and like Bayesian statistics and all this fancy stuff, right? Like computer algorithms for doing causal inference and blah, blah, blah. Because of all that and because of all these fancy methods we have, in a certain sense, like the scientific inference, like once you have like a data set, like the scientific inference on it, like, oh, what is the relationship between these two variables, like significant or interesting or whatever, that actually becomes less and less of an issue, right? Because your software just does that. Like there's like software now where like in R and stuff, where and in Python, where you just type in like, tell me about the relationship between these two variables, and it just kind of like automatically does stats for you, right? So like you're gonna learn it in this class, you're gonna also learn like how to do it, like the stats. But I'm just saying, it's kind of like how, you know, your calculator can do like graphing. So like maybe now that we have graphing calculators, so maybe we spend less time like drawing graphs and more time like analyzing them, right? In a way, I think, yeah, that's why data visualization is one of the two like new things that becomes like more relatively important now that we have computers that do stats for us in a way. But another one is measurement issues, right? Because sorry, I need to do this like hand gesture. I'm gonna like, it's like measurement issues is like the input into your study, right? Like you have to measure the variables like to get the numbers that you're doing statistics on, right? Data visualization is like the output. Like once you've done all the statistics, like what does it look like? Like, do I actually believe it? Like, does it make sense that these variables would be linked, right? So I'm just putting that down there, that there's like input to the process, the scientific process, and then there's like the output, right? Which is like pictures of what's happening in the phenomena. So for now, like, not for now, but if you think about it, measurement issues are like the most important, if in the sense that like, of those two, sorry, there's an argument that measurement issues are more important than data visualization, because only because of the fact that measurement issues like go into, like that's the input, right? If your measurement is wrong, everything after it is also wrong. Let me look at the chat real quick. Amazing. Okay, I'm glad you heard the elephant story before. Okay, yeah, because I felt weird saying it if you hadn't. Yeah, you can Google it. Like people are figuring out what an elephant is. I think you can Google that. Cool. Measurement issues. So it's like, yeah, it's like I was saying, like in the same way that has anyone ever just had like a really bad like microphone or something, and then it's like you record something, but then as you record it and as it gets like processed and like converted into different file types, it gets even worse, right? It's called like degradation of signal. Like it's a thing if you become like an engineer, like the more kind of like stages that a piece of data passes through, the more it gets degraded, right? It's entropy and stuff. But that's why I think measurement is so important, because it's the first step, right? Like if you mess it up, if you're something off about your measurement, or if you don't understand the measurement process of like what these numbers in your data set are, literally like everything else is invalid in like a logical sense, just because like everything else that you do follows from the assumption that the data is measuring the phenomenon that you care about, right? So this is a slide from Prof. JR, and it's the idea, like we hear these terms like economic prosperity, health, and well-being, right? We just like kind of hear them all the time. Maybe I don't know if like the average person hears about them all the time, but I definitely hear about them all the time. Like doing social science and stuff, people are just like, oh yeah, like economic prosperity causes health or something, right? Happiness causes like better fitness, or just like like these huge concepts like health, prosperity, like those are really loaded concepts if you don't like drill down into like what exactly you're saying, right? And so much of like science is, I'll just say, there's a certain science of the brain, like it's a field of science that has to do with studying the brain that I won't say the name of because they'll get mad at me, but like it is notorious for hiding, for like invalidating all their like studies, right? They're just not replicable. There's a replication crisis in this field. Maybe you know the one I'm talking about, but it's like because like they just have these concepts like happiness, like mood, meaning, meaning in life. And it's like, dude, how are you like measuring that, right? So measurement just becomes like such a huge thing. Cool. Is there sorry, there's a raised hand. Yeah.
Hi, yeah. So I was just wondering, like, would you care to like explain further what you mean by like they'll get mad at you?
Oh yeah. Sorry, I just like, because if there's psychology, it's psychology, right? It's psychology. It's,
Yeah, that's what that's
yeah,
what
I just I didn't want, if there were people who were interested in psychology, I didn't want to like sit here like trashing it, because like they like the replication crisis happened like maybe like almost like a decade ago now, meaning that psychologists have like that's what the field is doing now, right? It's kind of like stepping up their methods of scientific inference so that their studies are replicable, right? Because replication is like part of the falsification thing. Like if you can't like get the same effect between X and Y over and over again, you can't say like, oh, this is the relationship between X and Y. Like I found it through this study, right? If it's the relationship between X and Y, it should be it has to be the relationship between X and Y, like in all the cases, right? So if your sample size is too small, or if you do like weird statistical significance stuff, yeah, you're just like not doing good. Like the point is like, I'm not trashing psychology because I just want to be like, I'm bad at science. I like literally think it like matters, because, you know, people make mental health decisions and stuff like that, like physical health decisions, everything based on like, oh, I read a study that said that this, you know, eating coffee beans like makes me happier or something, right? And like, it's not, it's just weird. It's like, it's snake oil selling. It's like not true. Like there's what is it, like 70% of studies in psychology just like can't be replicated. So yeah, it's pretty wild. It's like a pretty bad thing. And so all I'm saying is like they're like recovering from it, but it was like a big like bad thing, right? Because all these people had been like, oh, what, I was doing like the Atkins diet and stuff and all this, you know, or I was like doing this type of like meditation because the psychology study like said it worked, right? And it's just, yeah, you want to avoid that. Like that's why it matters societally. So if it was 10 years ago, I'd pick on psychology all day. Right now, I'm like, okay, well, they get it. Like they've been yelled at about it. It's like they're doing like their work. They're getting better. So that's all. That's what I mean. Just don't be mad at me. Like I'm happy to talk with you if you want to do like psychology and stuff, and like not like trash it. Just like talk about it. Yeah, that's all I meant. Okay. Cool. So yeah, I just wanted to show like, you know, this thing here of being like, wait, what do we mean by that? I literally just like was like, okay, well, what would that look like? Like, what am I doing in my head? What should a person do in their head when they read like a scientific study, right? Like, oh wow, like this certain type of mindfulness causes happiness or something. So I just picked like this paper because it was open on my computer, because it's like the main paper for my dissertation, long story short. Meaning like I just picked it because like I know the variables and stuff well, and I can like dig into the different levels. But so I just wanted to use it to show you like, oh, I like pick up a paper, right? Or like I see a news article about a study, like what does this actually look like? What does it look like? The measurement, like caring about the measurement, right? And so yeah, this is a paper, like it's in the biggest econ journal, right? American Economic Review. And you can read the abstract, but I won't like go through it all, but I'll just go right to where like here I have boxed, right? You like read through it over here and you're like, we provide evidence that increased political influence arising from CIA interventions during the Cold War was used to create a larger foreign market for American products. Following CIA interventions, imports from the US increased dramatically. And then just for the sake of time, I'll stop there. Like the other stuff is kind of adding onto it, but the main theory is there. Because like now we can start to see like, oh, what are the variables that they're talking about here, right? Political influence. Like there's these verbs like political influence, create, larger foreign market for American products, right? you're almost doing like I almost imagine myself doing like a linguistic parse where I'm just like, what are the subjects of the sentences and what are the objects, right? Subjects and predicates. In this case, it's kind of like, oh, political influence, and then explaining what political influence is and how they're measuring it. And then was used to, right? That's like the verb. And it's like create a larger foreign market for American products, right? So it's in a weird way, like you're doing like a fancy linguistic parse and you don't even know it when you're reading an abstract like this. The point just being like, I actually literally do this. Like this isn't just an exercise I did for the class. Like if I have a paper, like I sit and I like draw these boxes, right? It's just so you know I'm not like BSing you. Like I think it's important. So yeah, and if you notice, like I differentiated between the like what happens to the variables, right? Like increasing or larger. Right? Those are like changes. Those are modifications, right? But these are the variables in the boxes, you know? So you just want to be able to separate those two, because sometimes I'll see students where like they'll name their variable like increased political influence or like larger foreign market, right? But like you don't want to include the larger and the increased. That's like a property of data changing, right? That's not like a property of data, if that makes sense. But the property of data itself is like, what's the name of this, what's the name of this variable? What's the name of this variable? Cool. And so we have the variables now, right? And then we also want to look for how they're measured, right? So that's like, I just put this so I want you to see the order, that it's like, you open a paper and you figure out what variables they're talking about, right? You figure out what pieces of data they were looking at. But then you also, right, this slide is like you're digging, that's the next digging level, right? You've dug to the next like level of the Earth's layers, right? Where now you're saying, okay, well, they say political influence. Well, that's like ridiculously vague, right? Like you could, like in the US, right? How do we politically influence people? Like what's political influence? It's like, well, advertising counts, lobbying, voting, like blah, blah, blah. These are all, so we need to know what you mean, right? So that's the like, that's the second box that gets added here. Is like, oh, okay, it's not just like, they're not just leaving it at political influence. They're saying like, oh, increased political influence would happen when there's a CIA intervention, right? You overthrow a leader that didn't like you, you put in a leader that liked you, bam, more influence, right? And then same thing for the Y variable, right? The dependent variable. For larger foreign market for American products. It's like, well, what does that mean? Larger, right? Does it mean like more products are getting, more American products are being sent abroad? Or does it mean like not more products, but a higher number of the existing products, like there's more importations of the same products, stuff like that, right? Like these are all, it's all digging in, like, because you have to not let them like hide things under the names of the variables, right? You need to like literally be able to imagine like, okay, wow, all right, like economists like go out, right? And they like mark crates of goods as they go between countries, right? And this all gets tabulated into a thing, imports from the US, right? Like, I think it's like important to get to that level of granularity, right? Because then you don't have to worry about like the measure, that's how you like alleviate worries about measurement error, right? Is you just dig in as much as you possibly can with like the brain power or energy that you have to that, right? Because we could even dig into this right? There's a kind of infinite digging. You just stop when you're like satisfied. Because we could say like imports from the US, well, does that like is it like all goods or like taxed goods or like goods that people take with them when they immigrate? Like what do they mean like imports? I mean, there are accepted definitions of imports, but like you should like look them up, right? If you're gonna like think about, do I believe the claims of this paper? Right, so cool. I just wanted to put that as like, this is an actual mental exercise that someone actually did to like understand this paper. Cool. So yeah, point is, it's the thing I was talking about before, where if your measurement is messed up, then your inference is definitely going to be messed up. Before we you can think about the relationship between X and Y, right? Like, does X cause Y? Does Y cause X? Do they not cause each other at all? Do they mutually cause each other? We want to know that actually like X and Y are valid in the first place, right? We want to understand them, how they came, and any issues that might have come up in their measurement, right? Correlation versus causation. You've probably heard that a million times, like correlation doesn't equal causation, but, and to the point that it gets kind of annoying, I think. But yeah, we're finally going to dig into that and see what that actually means in this class, right? Which is just like, correlation is just things tend to change, quote unquote, together, right? Two variables tend to change together. So higher values of X tend to co-occur, quote unquote, with higher values of Y. And this diagram I love so much. I like just found it last semester we were teaching this, because it just shows like, don't worry about the like plus signs and minus signs for now. You will later on in the class, but for now, just look at like, oh, these are like two things that are correlated. It literally just means like, oh, high values of the X also like co-occur with high values of the Y, right? Like each of these points is like a piece of data that we have. And so like, this is like, say like a person, this is like their height in meters, don't worry about it. This is their weight in kilograms, also don't worry about it. I'm just making it up. But the point is like, each of these dots is a person, and it's like, oh, people with higher height, look, they also have like higher weight. Like when a dot is to the right, it also tends to be at the top, right? Whereas here, they're just all spread around. Like you can't say like, oh, a person with a high weight also has a high height, right? Because there's all these examples down here, people who have high weights but low heights, right? But causation's trickier than that. You can get tons of graphs like this and not have causation, right? Which we'll see, right? Prof. Sperling like showed this in class, the like Nick Cage movies and people drowning, I think it was. But I kind of went like ham on that website. There's a website, I linked to it here, where like it just lets you generate like correlations, because it just has tons of variables and you just pick two of them and you like see what their correlation is. So I spent way too long on it last night, and I probably looked at like 50 of them, you know, something like that. And this one is like the highest correlation I found. It's like 99.9, right? You see down here, correlation 99%. And it's pretty beautiful correlation, right? 99%. It can't get, there's no number higher than that unless it was 100, which would mean it's the exact same line, right? So this is the highest possible correlation you can possibly get between two variables. And it's like total revenue generated by skiing facilities and lawyers in Georgia. And I just loved it, because yeah, you like sit there and some of them you can come up with examples of, like some of the ones on the site are like rainfall and like Disneyland revenue or Disney World revenue. It's like, oh wait, no, that makes sense. Like when it's raining, people don't go to Disney World as much. So like there's some of them actually like, oh, they make sense, even though I picked them randomly, but some of them are just random. That's why like monkeys on a typewriter. Do we know that story that like, if you just have if you just give typewriters to a bunch of monkeys and give them infinite time, they'll eventually type the works of Shakespeare, right? It's just a weird thing. Like if you just keep like, if you just take all the variables in the world and you just keep finding correlations between them, like just due to like mathematical chance, you'll get correlations like this that are like 99.9%. So you can go on that site and like look at them. They're fun. Yeah, sorry. So that was spurious correlations. Like that's one thing that where it's like correlation doesn't imply causation, because it's just, dude, you tried so many. Eventually you were going to find one with a high correlation. You didn't actually look at the causal. You didn't think about the causal mechanism for any of it. And then the other thing that, the other kind of like pitfall is that you can see correlations. There's a missing variable, right? So do we know this one? I can't remember if Prof. J.R. Sperling talked about it in class, but umbrellas causing car accidents. Anyway, it's like, this is participation fun, which is like, do we know why umbrellas would cause car accidents? Meaning why we would think they do, like days the high umbrella use also have high car accident frequency?
I guess because it's like raining.
Bam. Yeah, 100 points to Gryffindor. Not real points, not redeemable for the class, but that's exactly right. Yeah. So just keep those points in your like satchel for sure. Like they'll come in handy later. But yeah, thank you. Because right, like you can make a graph, right, which is like each dot is a day, and the x-axis is the number of umbrellas that people were carrying that day, and the y-axis is car accidents, right? And you'll get something like this, right? But in this case, we think it's just spurious. Although maybe you could add like a million variables and eventually get like the link between those two. Here, like it's actually not that hard to fix it, right? Meaning like go from correlation to causation, because it's like, oh, the umbrellas aren't causing the car accidents. The rain is causing both people to carry umbrellas and people that have more car accidents, right? That's we were missing something in our theory. Cool. And that's why like for causality, like that's why counterfactuals is here in the title next to causality, right? What would have happened if, so X causes Y if like X happening is what made Y happen, in the sense that if X had not happened, Y also would not have happened, right? So we need to always like think counterfactually if we want to do causation, right? That's kind of the leap. Like think of it, you're in like correlation world and you're like not actually like finding the relationships between variables, where you're like stumbling around, just like, guys, I can't figure it out. Like, why is like skiing revenue making more lawyers? And like, why are umbrellas making car accidents, right? And like, you want to go to causation? Yeah, you gotta start thinking like counterfactually and start making sure you have all the variables right. So the easy mode for establishing this causality, right, is you do an experiment, because you literally just a controlled experiment in a lab is like holy grail, because there you're just taking a bunch of people, right, and you're essentially randomly, you're randomly either like giving them a medicine, say, or not giving them a medicine. And so like the counterfactual is, the true counterfactual for a medical study would be like, wow, what if we could like split the universe into two universes? And in one universe, we gave the person this medicine, and in the other universe, we didn't give the person the medicine, right? And then we saw like in those two universes, like, oh, in this universe, they were cured of their disease, whereas in this universe, they weren't, right? Then we could be like, oh, nice, that's great. The medicine caused them to not have the disease, right? That's like unattainable holy grail, right? Because of the fundamental problem of causal inference, which like I'm running out of time. So yeah, I will probably, yeah, I'm gonna end on that meme. So give me 60 seconds, because yeah, causality, holy grail, easy mode is an experiment, hard mode is observational data, but actually even in easy mode, you still face the fundamental problem of causal inference, right? And the reason why medical studies address that the best of any like methods is literally because like the patients are just randomly, there's no characteristics of the patient that are determining whether they are getting the medicine or not. It's just like random, right? So the way I want you to think about that, like it might not get emphasized as much in this class, just because like there's certain ways of thinking about the fundamental problem of causal inference. My way that like suddenly clicked with me one day when I was in like grad school, like stats class, was like, oh, you can like pair people up, right? You can like take two people, they might be twins, right? And you can give one twin the medicine and the other twin don't give them the medicine. Then you're getting like super close to the holy, unattainable holy grail, right? It's not the same person in two separate universes getting the medicine and not getting the medicine, but it's like two people with really similar genetics, right? And so medical studies, like they try to A, randomize, but B, also like you can like pair people, like, oh, these two people have the same height, the same weight, the same pre-existing like conditions, blah, blah, blah. So like we gave one the medicine and we didn't give the other one the medicine. Those are really good comparisons, right? In terms of getting at, oh, what would have happened? Like if I had taken this person, but not given them the medicine, or if I had taken this person who didn't get the medicine and gave them the medicine, right? Okay. And I just want to end on this because it's like, what can you do with the fundamental problem of causal inference? Forget everything. This is my favorite meme of all time. I won't harp on it, but it just makes me laugh so much, and I have no idea why. It's just so cheesy. I just always, keep it in mind that we can forget everything and run. We can say, oh, it's causal inference. It's too hard. We can't do it. Or we can face everything and rise and just do like science. And we'll talk about it. I'll finish it next week. But yeah, the point is like you do good enough science, you do good enough, set up good enough experiments, do good enough data analysis, you can like make huge dents in the fundamental problem of causal inference. That's where I want to end it, because next week we'll learn about those dents and like why they actually do make the dents, right? What the techniques are and why they chip away at this fundamental problem. So yeah, I'm so sorry for keeping you over with all the tech issues. Thanks. Have a great weekend. And email me with any questions, especially on this with like, it was a lot. I rushed through a lot. So, I'll stop the recording if you want to ask.
Okay, so are you